Let P, Q, R be any three sets. Consider the following two statements. P minus Q minus R is equal to P minus Q union R. P minus Q union R is P minus Q minus R, which is the following is true. 1 and 2 are always true. 2 is always correct, and 1 is correct if and only if P is a subset of R. 2 is always correct, and 1 is correct if and only if R is a subset of P. Both 1 and 2 are always incorrect. Let's go step by step. P minus Q minus R is equal to P minus Q union R. Right? So P minus Q minus R. Q minus R is elements in Q but not in R. So if you look at this, elements in Q but not in R is basically this. P minus this, elements in P but not in Q minus R. Elements in P but not in Q minus R. Not in this. So this P minus Q minus R is set of elements in X, M, Q. Just regions X, M and Q. There could be a bunch of elements in X, bunch of elements in M, bunch of elements in Q. P minus Q union R. P minus Q is in P but not in Q. With X and M. Union R. X plus M plus Y. So P minus Q union R is X, M, Y. That is X, M, Q. This is X, M, Y. Nice. X, M, Q and X, M, Y. So they're not equal. Let's go to the next one. The first one is not always true. P minus Q minus R in P but not in Q but not in Q but not in R. So Q minus R is this region, in P but not, that is X, M, Q. P minus Q is X and M. Sorry. P minus Q union R. P minus Q is X and M. X, M, Q, P, Y. Everything. Sorry. X, M, Y, P, Q. P minus Q union R is in P but not in Q, which is X and M. Union R, just M, Y, P, Q. So M, Y, P, Q and X, all of them. These two are not equals, we don't have to worry about it. Statement 1 is not always true. Statement 2, P minus Q in union R in P but not in Q union R. P minus Q union R. Q union R is the whole thing. In P but not in this is P only. That is X, region X. P minus Q minus R. P minus Q is in P but not in Q. Leaving this out, X and M. P minus Q minus R is in P minus Q but not in R. X and M but not this. P minus Q minus R is also region X. Nice. P minus Q union R is in P but not in Q or R. It's only P. P minus Q in P but not in Q minus R in P but not in Q nor in R, only P. So the second statement is always true, which is beautiful. First statement not true. X, M and Q, X, M, Y, P, Q. But funny thing here is choices say 2 is always correct. And 1 is correct if and only if P is a subset R. 1 is correct if and only if R is a subset of P. So let's look at this. I have to want to verify that. P minus Q minus R is regions X, M and Q. This is X, M and Q plus P and Y. And P and Y are elements in R but not in P. If they are elements in R but not in P, then these two won't work. But there are no elements in R that are not in P. That's every element of R, if it were also an element in P. In other words, if R is a subset of P, if R were a subset of P, this would be 0, this would be 0. Being nothing in those regions. Elements of R but not P simply wouldn't exist. If that were the case, then P and Y regions are practically empty. Which means this is also X, M, Q, that's also regions X, M and Q. Or statement 1 holds good if R were a subset of P. So Statement 2 always correct, and 1 is correct if and only if R is a subset of P. Only if R is a subset of P. If that is not the case, there's something in this region, it won't hold good. If there's nothing in this region, it will definitely hold good. Both ways it holds good. So we're looking for the choice which is, this is always correct, and that holds good only if R is a subset of P. Beautiful question. Super challenging because you have to look at each of those regions, each of those subclasses. We know that the second one is always true. It eliminates only one choice. Straight away you can sense that you have to imagine R being a subset of P or P being a subset of R. Then R being a subset of P really works out.